And we're live. Welcome to Substrate Seminar, everyone. Super stoked to have Javier here, who's going to be presenting Zombienet. So Javier is a simulation network lead. He'll tell us all about this. But I'm excited to have him on board because he's been working on this tool for almost like a year now, I think. Pretty much, I used it in November last year. So just real quick for the newcomers, Substrate Seminar is a bi-weekly developer learning session. So we have a lot of builders in the ecosystem and a lot of different types of tools being built and all sorts of parachain teams also building infrastructure and applications. And we meet twice a week to talk about what they're building. So this seminar in particular, you'll learn how to use Zombienet. Zombienet is a framework for testing parachains, and Javier will tell us all about this, but it's really built to be as flexible as possible for your own use cases. So this seminar is actually really useful for those looking to build and test with the tools out there. So let's throw it to you, Javier. How's it going? Maybe you could tell us a little bit about your journey so far building this tool and what you're most excited about in presenting it today in seminar.
Okay, thanks, Sasha. Thanks for having me here in the seminar. So yeah, we are almost a year ago, I started building Zombienet. So yeah, I'm super excited about the development of this tool. And I think it's a super useful tool for the community. We use it internally in Parity in a few places, but we have like also a roadmap with more features and more things for the community. But if you agree, we can like start the presentation and I will deep dive on how to start using Zombienet, like starting small with a little examples, and then we can see the flexibility and all the possibilities that you have with the configuration and all the tests that Zombienet has built in, allowing the developers to just focus on build things and not like create test framework or something like that.
Yeah, I think that sounds like a plan. Let's dive right in. Before we just do that, I want to remind you, the audience watching, that you can access sort of the write-up, the plan for today's seminar. We actually have a dedicated Substrate Seminar repository where you can also find previous seminars that are posted there. But for example, today you can actually like check all the links and the things that we're going to be talking about today. Similarly, if you have any comments, you can use the discussion part of the repository to like post your comments. And those of you watching live, please use the ask a question box if you have questions, and feel free to just use the chat to engage with the audience. So with that being said, I'm going to leave it up to you and go on mute, Javier, and the floor is yours.
Okay, thank you, Sasha. So let me just start the presentation. So the idea for this seminar is to have a walkthrough about Zombienet. So first, as Sasha mentioned, my name is Javier Viola. I'm working at Parity as simulation network lead. And I started working in this project 1 year ago, or almost 1 year ago, and with the goals of create this integration testing framework that allows users or developers to have a smooth like experience when they try to spawn networks and test the network that they spawn. So what is Zombienet? Zombienet is a project that, as I say, I started last year, but it's a latest iteration of a simulation network tools. There was another project that Parity works internally before Zombienet. And when we start with this project, we set the goal to build it, focus on the needs of the different teams. Should be a tool that should be flexible, that everyone inside Parity or outside with the ecosystem should use this or can use this tool to create tests and to make spawning the network easily for users. So what is Zombienet? Zombienet is an integration testing tool that allows users to spawn and test ephemeral substrate-based networks. We call this ephemeral because everything that we spawn and the test is cleaned up when we finish the monitoring process or the testing process. and we support each. We have the goal to support different substrate-based network. At the moment, we will see later. But why we start this project is at the beginning. So to see what are the friction that we recap when we start the project, we can follow in, for example, a few tutorials. For example, the simulation network tutorial in the Substrate documentation page. And you will see that, for example, this is great because you have all the information about all the commands and all the things, and you can learn how things work here. But you can see there is a lot of command that you need to just like run to run a two nodes networks. And this is like error prone, and if you have to if you have to spawn this network several times in your day, it's like a very tedious work to just copy and paste or create a shell script with this command. We have also
so maybe Javier, we can just, if I may interject, can we touch on what are the current tools out there, right? So what you just showed in our documentation, I think it touches on using a tool called Polkadot Launch, where we do have ways of creating our own simulation network or simulated networks. However, I think what you're highlighting here is that there's a lot lacking in this toolkit right now. It's maybe not as intuitive. It's a little more clunky. It's harder to use, right? So maybe you want to comment on what are the current tools out there right now, and maybe their issues.
Yeah, no problem. Yeah, when we start looking for other tools to get inspiration about it for Zombienet, there is a tool that is the most used for the teams or internally is Polkadot Launch. That tool has like the configuration was not so flexible. You need to specify all the ports, you need to specify different things, and also only works with binaries. So you need to compile everything, and you have to have all the binaries in your laptop just to launch a network. And they have like a different friction related to how you can configure with different, for creating, for example, big networks with different parachain and stuff like that. So there is that tool that is mostly used in the ecosystem, and the idea is deprecate that tool, or when we say that Polkadot Launch is the go-to for launching this substrate-based network, we want to move to deprecate that and start working with Zombienet for all the teams, because Zombienet has a more flexible configuration, support different environment, not only with binaries. You can work with image locally or with image in a cluster of Kubernetes, for example. Mm-hmm. And related to the tools, there was another tool like Starships, and I think is another one that is Parachain Launch, if I don't remember the name, that makes like similar things. But one thing that all these tools doesn't have is a test runner. So when we start Zombienet, we take the decision to build in a test runner in the tool, so we can wire the spawning and the testing phase.
So I think I think that you answered the question very well with Polkadot Launch. There's two questions that came up right now in the chat. The person is curious in knowing just kind of the key differences, and I think highlighting that the main thing being, it's much more difficult to use and less sort of accessible, like from different sort of developers working with it, right? You need to use the binaries, you need to use Rust, and like there's much less flexibility, basically.
Yeah, so to highlight the difference with Polkadot Launch, I think one is the flexibility for the manifest of the network configuration. In Zombienet, we take the approach to have several default values built in, and you don't need to explicit say a lot of things that Polkadot Launch needed. And the second big difference is the support for running not only as a local process, running like image or in a cluster or in a local container or something like that. We can see that in a few moments. So that two are the main difference with Polkadot Launch. and also the test runner, because Polkadot Launch allow you to just launch the network and you can start playing, for example, with Polkadot.js or something like that. But with Zombienet, you can automate your test using the internal test runner.
So I think to answer one of the questions that just came up also is, so the question is Polkadot Launch the only inspiration, or is there other things being used? I think that the idea here is like Zombie, we're going to learn about this right now. I mean, the seminar is that Polkadot Launch is just one piece of the puzzle, right? Where Zombienet has a lot more features than Polkadot Launch. So it's in a way somewhat of an inspiration. Maybe you can just comment on that.
Yeah, it's in a way some inspiration take from Polkadot Launch. And there was another project internally that we call SimNet, that was the previous iteration from Zombienet. That is also, we take inspiration and patterns from there, because it was a tool made for also testing or integration testing. So we have these two main inspiration from Polkadot Launch and SimNet, and we try to reduce the friction from those tools and just grab the good things or the patterns that inspire Zombienet, and to create a smooth tool for the developers.
Awesome. Thanks for answering those questions.
Yeah, no problem. So yeah, going back to the presentation, the idea is to recap on why Zombienet. It's as I said before, there was another tool like Polkadot Launch, or if you go to the Substrate documentation, you can see all the commands, and that is really good because you can learn a lot from there. But to the day-to-day developers, they want a tool that allows to easily spawn networks, for example. So one of the things that you can do with Zombienet is, if you try to simulate, for example, the same network is launched with this tutorial, the simulate network. In Zombienet is super easy. You can just, for example, I have here all the examples from the tutorials. If we want to see the configuration, we need to launch the two validators or two nodes network from the simulate network. You can see it's really easy. It's a few lines. When we define the chain, we define what is the command. We are basing here in the node template using the same template from the documentation, and we define a few nodes. And from Zombienet, you can just download the release. There are binaries for macOS or for Linux, or you can, if you want, clone the repo and build it from the source. The project actually is written in TypeScript, so you can clone the project, you can compile, or you can build the project, and you can use it from there. And just to show you what is the CLI that you can receive with this binary, it's super easy. We have two main features: the spawning phase or the spawning command and the test command. You have also the setup command that set up everything for you just to start playing with Zombienet. But we will show here how we spawn this network. It's super easy. You can say something like this. We have the provider. We will use the native provider. We will run everything locally as a process, the same way that Polkadot Launch does. And in this case, we want to spawn the network, and we just pass the network definition file. This is a TON format, but you can also use JSON format if you want. So we support both formats. And as you can see, there is a really nice output thanks to Nikos, that is create these beautiful tables. And you see a lot of information. You see how the provider that you use. For each network that you spawn, Zombienet automatically create a namespace. That is, when you run locally, it doesn't make more sense, but when you run in Podman or in Kubernetes, makes a lot of sense because it's all isolated in that namespace. Also, Zombienet will create a temporary directory to just put all the working files in there, all the logs from the nodes, all the configuration that you need is all there. So you can go to that directory and reproduce all the network launch that you have, or you can see all the logs. And as you can see, there is a few steps that Zombienet does for launching the network. And when the network is done, you see this nice output when you can have direct links to click and go to Polkadot.js to connect, for example, to this node. And you can see it's already running. This node is producing blocks, finalizing, so you can use it.
So can you comment on like what we're just seeing right now? It's a local testnet in a way, right? So we've got it's you spawning a relay chain node. The question I have in my mind is sort of what would you do once you have that? Like, is it then are we going to connect the parachain to it? Like, what about this tool? Like, in using it natively, can I kind of do that's useful or exciting or you know? Does that make sense? Like, especially compared to what we already have, you know?
Yeah. So you can also here we just launch a really simple network, but you can, for example, if we are working with a parachain, for example, and we want to just launching this local test network with the parachain already registered and producing blocks, you can just specify the parachain. Let me show you the first launch, and we can see how we specify that. And for example, if you are working on a parachain and you have, like, you want to spawn in the network, connect your parachain, and start see things in Polkadot.js, for example, the event or like making a string-seek or something like that, it's super useful that you can spawn in the network and you have the direct links for everything already working. The parachain by default is automatically registered in the relay chain in the Genesis, but you can make it that is not there, is not registered, and you can register later if you want. So for example, right now we launched the same network with the 2 nodes, but with 1 parachain. So if you go to one of these, you will see that the parachain is already here. It's not producing blocks yet because it's recently launched, but in a few seconds you will see that it's producing blocks. You can also connect to the RPC of the collector. And here you also have these links to the Prometheus metrics that the nodes expose. So you can easily query the metrics from the node. And we will see that Zombienet use these links of the metrics to create assertion for your testing. So at the moment, spawning the network is the same goal that the other tools have. For example, Polkadot launch or parachain launch make the same. It's spawning the network and just giving the information about the network. That is the same. We have like more flexibility in the configuration files, but it's the same goal that we want to just launch in the network. If you see the file for launching this network, again, the network configuration is simple and flexible. You define your chain, you define what is the default command for the relay chain, a few nodes that in this case are marked as validators. You define your parachain, what is the ID, will have that parachain. The collator, what is the command for the collator. And in this case, if you have custom types, you can define the custom types here. This configuration is very similar to the Polkadot launch configuration. So if you have some Polkadot launch configuration that already you are using for your work, you can migrate those for using with Zombienet really easy because it's very similar, and we have the idea of creating a tool for migrating configuration from Polkadot launch to Zombienet configuration, but it's I would say that 65% or something like that is similar, so it will be super easy to migrate from Portal Launch to Zombienet.
Mm-hmm. I mean, I think, yeah, like the idea, it's so clear, like how much more flexible it is to launch your testnets this way. Bearing in mind that this is just one part of Zombienet, right? Zombienet is really more of a testing framework. That's the key piece, the first piece to solve is to make it easy to launch a test network. So I think it's a no-brainer, definitely a lot more attractive to use the CLI tool than the copy pasting that you need to do with Polkadot launch.
Yeah. So the Zombienet is a test integration framework, but we need to first launch in the network for testing. So that is like the first phase of Zombienet. But just to recap on what we are doing with Zombienet right now, if you see what are the goals for the spawning phase that we have when we start like building Zombienet, it was, okay, should be really easy to set up the network. Should be hassle-free. And we support Tom and JSON if you want. We also want to support multiple environments. We want to run locally as we are running now. We want to use containers with image because several teams that build image and send image to the registry, and they want to test those images and spawning new networks related to those images. And we also want to support Kubernetes as a cluster or working with that container cluster. And should be fast and reliable. So we spawn nodes in batch if you want. If you need to spawn like a large network, for example, I don't know, like hundreds of nodes, something like that, you can specify the concurrency to spawning the node, and we spawn the nodes in a concurrent way. It's super fast. But what are the things that Zombienet does for you in this phase, in the spawning phase? We are customizing the chain spec for putting everything in place. All the validators or the keys are managed with Zombienet. So when we build a chain spec for your relay chain or for your parachain, we ensure that everything is in the place it should be and everything should work. You don't care about, for example, the keys, or you don't need to register the keys of the validators or rotate the keys. Everything is like in place for running the network. We also create all the commands for the networks for the nodes. We create the command with all the flags you need, and you see the command, so it's easily to reproduce. If something failed, you can just copy and paste the command, and you see how the node is working or what's happening there. We create a port mapping. When you use the native provider, we don't map the port, we just pick 3 ports, but when you use Podman or when you use the Kubernetes cluster, we create all the port mapping to access to the RPCs or the metrics node from your laptop. We register all the parachains that you want. So by default, all the parachain defined in the network file are registered in the Genesis. And also super important, we create an auto cleanup process when you just like killing this network. We clean all the process, we clean all the things. The files are in a temporary directory, so we will be cleaned automatically by the OS when you, for example, reboot your machine. But when you work with Kubernetes, for example, we create an auto clean process that will clean the namespace, we clean all the resources in there, because we don't want to just having spots of things like that in your cluster that is not in use. So everything is cleaned automatically by Zombienet. And as I said before, one thing that is super important for us is to support different, we call providers. At the moment, we support running process, as I show, running Podman locally or running in Kubernetes. We are working on more providers. We have in the roadmap for Nomad, and also we want to add support to Docker. And related to the network definition, in this place, I will talk a little bit about the network definition and the big blocks. But for example, if you want to see something more useful, In here, we can see how we spawn a network in Podman, and there's a few things in Podman that is.
Javier, can I just interrupt
Yeah.
you to ask that you make some space in your terminal, because we can't actually see the command that you're typing. Just like if you have press enter, yeah. Press enter like 3-4 times.
Oh.
Yeah. Because then that's so that we can see.
You can see?
Nice and clear. Yeah. Better.
Okay. So let me show one thing about Podman that is nice also, is that we also think the providers as tires. So in the ideal developer that use Zombienet, or we think how is the ideal use of Zombienet, is that the developers work locally first with the native provider, as we see, with like building the parachain, and they need to running the things that they compile. But when they want to create like a more robust test or something like that, they can use, for example, build an image and use Podman, and they will receive also the monitoring stack in there. We spawn a monitoring stack based on Grafana, Prometheus, and Logi for the logs. So, for example, if you use Podman, you will receive that, and we can see when we spawn a new network using Podman in here. Not only is spawning network, it's spawning the monitoring. So we spawn a Prometheus, a tempo provider. So everything that the metrics that you will or you want to see, you have access in there for that namespace isolated for your network. So that is great for like when you are done with the unit test, or you want to create a more robust test, or you want to see something in metrics, you can use Podman, for example. And the same is with QRNets. So if you use QRNet, you receive the same stack for monitoring. And that's the idea that we have with the tiers of providers. It's like, or how we use internally is in that way. We start with the native, and then you can use Podman or Kubernetes. In our case, we use Kubernetes also in our CI, so we have all the visibility and observability in there. So going back to the presentation, how do we define the network? We have like three main blocks or three building blocks. The settings for the general network setting, for example, the timeout for launching the network. If you want to use a boot node or not. If you decide to not use a boot node, we just pick the first from the relay chain to be the boot node for the other nodes. If you want to enable tracing, if you enable tracing, it's only for Podman or for Kubernetes. We run the pods with a sidecar of Jagger that we can use for tracing. In the relay chain, for example, we base the configuration in a node, or you can use a group of nodes to allow to specify, like, I want a group of nodes, a group that have, I don't know, like 20 or 40 nodes, and another group with 2 nodes or something like that. Or you can specify one by one the nodes. In the examples that I showed before is with 1 by 1 node, but you can use groups, and you can specify the default for the groups or for each node in the relay chain. And also the parachains is an array of the parachain configuration. So you can see the ID, the chain name, and the collector to running that parachain. If you click here, I will share the presentation later. You see the documentation with all the possible settings that you can use in the network configuration file. There is a lot of things, but as I said before, we try to make these tools flexible for everyone. So most of these things you can set if you need it, but if you don't set, we have a default for you, and everything should work without need to set as much as you can see here that we have a lot of things to set. Another thing that is useful for defining your network with Zombienet is that we use Nunchucks as a template language is very similar to Terra, from the ones that are in Rust, or the Jinja templates from Python. So you can define variables with these curl braces, and will be replaced to your environment variables. And this is useful to have a default configuration, and you can specify in your environment variables what are the images to use, so you don't have to go and like changing every time that you have a new image. Or for example, in the CI, you can specify the version from the CI shop that build a new image, and you have the same configuration for all the CI shops that you have.
This is super powerful. Like just using a templating tool like that, you know, it allows you to really configure things, especially in the CLI. I imagine it makes it much easier to build cool features in the CLI.
Yeah. Yeah, and also for continuous integration shops, because for example, we have Zombienet working in the Polkadot repo, and we build a new image for each PR that we have. So it's the same time, it's the same test network configuration. The only thing we change is the environment variable to define what is the image to run the test. So it's super useful for this kind of tools, or this kind of scenarios when you want to have one test and use that network configuration for all your tests, and you just need to change the version that you want to run. A few examples, as we see before, we can define a parachain, or we can define a group of nodes. I don't have here, but we can see more examples here. So for example, if you see, I don't know if you are maybe like this. In here, we are using the node groups to define groups instead of define each node separately in the configuration. The same you can do with the collators. You can define a group, and you can specify what is the command for running. And you can mix. You can have nodes defined and groups defined. You can mix in here in the relay chain, have 2 different groups and 2 different nodes if you want. You can use that.
So is this what we're looking at actually, or on this slide too? Is it what the Polkadot CI is using, or Rococo?
Yeah, for running the test in the CI, we are using Zombienet with a different configuration, but it's this tool that we are using. So Zombienet has these 2 main files. One is the network configuration that is in a toml of JSON format. And the other file is a feature file that we call, that has all the assertion that the test will run. So until here, we see the spawning phase. I don't know if there is more question related to how to spawn a network, or what thing that's supported.
No, yeah, I think there's no more questions on that. It's super clear. Like, key takeaways is it's much easier. It's more flexible to spawn your network. You really can do so many things depending on what your use case is. But maybe we'll talk more about sort of different audiences, different people using these tools. But I think actually there's a question that just came up. Let me check. So yeah, there is a question about, so the question is, what is minimum required data from the node to be able to be used with Zombienet?
So the minimal configuration should be if you are in the native provider. So if you are in the native provider, as we are here, let me show you. The minimal configuration is the relay chain that you want to run. The default command, that command will run in each node, and you need to specify the node name. You don't need to specify the validator if you don't want. By default, this node will be validator if you don't specify. So with this, you can run the nodes. It's the minimal configuration for the nodes.
And I think, I mean, the question was asking what the minimum amount of data is, but I think what the person is trying to ask is sort of like, what do I need to just get it up and running? And the answer is, well, at the very least, you know, you need your the binaries of the chain that you're running. And the chain spec and these things that in no matter what situation you would need, right, to launch the network. So is that correct, Javier?
No, for example, for using the native provider, you will need only, in this case, the node template compiler is the only thing you need, because the chain spec will be generated by Zombienet, so you don't need the chain spec. You only need to compile the binary and just specify this network file. For example, if you are using an image, you can specify the default image here and the command for the image, and you don't need the binary. Will run in a Podman, for example, or Kubernetes with that image. That is the only thing you need. You need to know the image, the chain you want to run, and what is the command for running that image. For example, if it's a polka-dot image, you need to say the default command is polka-dot, and if it's a node template image, you need to specify this command, right? But you don't need
that makes sense.
Somebody take care of all the configuration, create, for example, the chain spec, the genesis for the parachain, the WASM for the parachain, and just to put that in the chain spec of the relay chain. So everything in that is already taken care by Zombienet.
Cool. That's again like so powerful, so useful. I'm really excited about this. Yeah, I think there's no more questions on that, so you can definitely jump into the next section unless you wanted to say a few more things about this.
No, it's okay. So and here we have the spawning thing is the same that you end up with the same that Polkadot launch, for example, or Parachain launch is a running network, right? But when we start working in this tool, one of the goals was creating a integration testing tool. So we have the running network right now, how we test this network. And we define that we will have a built-in test runner that allow users to use a simple DSL language to easily and intuitive write test. So it's super easy to write test. We are using a set of natural language expressions to make the assertions. And also, as a goal, we have not only to create this DSL that should be really easy to write test, should be also extensible and flexible. You can see now that we have a couple of assertion providers that allow you to test like on-chain things, run scripts or JavaScript that connect you to your network. You can also run scripts in your nodes directly if you want. So, but let me first show you one test. For that, let me, I think here will be fast. So the CLI has the two commands.
Javier, can you just make it so that we can see the command again? It was, yeah, that's going to be better.
Yeah. You can see now?
No, maybe enter. Yeah, I can see now. Yeah, okay, cool.
Yeah, okay. So again, we are using the Zombienet macOS version of the binary, and we say that the provider we want to run is the native one, but this time we want to run a test. And in here, we will use the local parachain.
Maybe a tiny bit more zoomed in because the bottom is being cut off by half. Yeah, that's good. Thanks, yeah.
Okay. So here we say we want to with this feature file. So let's check what that feature file make. The feature file has like a header of the feature file for the test. We have the description that is optional, just to print the description about this test. We define the network that we want to spawn, because every time that we run this test, we spawn the network and then run the assertion through that network. And the credentials, so where is the config file? But this is only to use with Kubernetes. So by default, you can leave as config or libentity is okay for using the native provider. But if you are using Kubernetes and you want to use different config files, you can specify your config file in there. And these are the assertions that I mentioned before. We can use, let me just run this and we see the result, and then we can talk about the assertions. So the first thing that Zombienet does is spanning the network. As before, it's spanning two nodes network and one parachain with one collector. We receive the information about all the nodes, and we start seeing the test runner working. In this case, we are testing that the two nodes, Alice and Bob, are up. What are the node role that is reported by Alice is 4. That means it's a validator. Another report metric from the node. And then we expect that the block height of Alice should be at least 10, between 108 and 80 seconds. So this can take a while to get that. But as you can see, we have different assertions. We call the well-known function. There is a few assertions that we use everywhere. So for example, is up is just checking that the node is up. And then we have an assertion related to the metrics. We use the Prometheus embedded server that each node has to just scrap the metrics and then compare the information from the metrics to the feature file and assert that the measure that we want to check is at the correct number. For example, in here we say the block height of Alice is reporting is at least 10. Okay, now it's okay. And then we can also make assertion related to the parachains. For example, we say, okay, we want to see if the parachain chain, where the parachain 100 is registering, and each assertion support this between like language that say that we can wait until, for example, 225 seconds to see if it's registering. So Zombienet will try to check that every few seconds to see if it's registering, and if the timeout is hit, the test will fail with a timeout. The same, we can check the block height for the parachain. It's here, and we have a couple more. We can check the logs of the nodes. For example, if you want to see if some log line match with the expected output that you want, you can use glob pattern to match on the line, or you can just match the line using a regex pattern. We can also subscribe to system event and see if in the node we see an event that match with the pattern that you want to search in this event. For example, a candidate was include. And we have a couple more here. Let me show you the full list. As I said before, the reports that we have is based on Prometheus metrics, so we can assert on all the metrics that the node reports. We have also histograms also support. The node reports histogram through Prometheus also. You can specify what are the values you want to see in the buckets of the histogram, and we can assert on that. We can assert on the logs of the nodes, as we see before. We can assert on or in the chain system events. We can check the on-chain storage if you want using custom.js, for example. And we have a few assertions that is only available if you use Kubernetes. It's the tracing spans, the back channels that allow you to coordinate attacks between different nodes. And also we have support for Polkadot Introspector. That is a really cool tool that allow you to learn things or introspect things from Polkadot. You can see in the repo. And one thing to notice here is that we can see that each line of here is a test, it's an assertion. This is a DSL that is sometimes it's hard to figure out how to write the test. So we also have support for having, let me found here, snippet. We have a VS Code extension with a few snippets. So you can easily go here and install the extension. And then you can.
Okay, that's really cool. I was gonna ask, like, how are these tests written? Like, what's what do I need to know to get started to write like tests that are custom to my use case? And the answer is that it's a DSL, and there is a VS Code plugin to help you like understand the
it's an
syntax of it.
extension that allow you to it have all the snippet. For example, if you want to just run a JS script, you can say JS, and you can, for example, with argument or without argument, and we'll have this snippet just to complete for you. One thing related to the JavaScript assertion is that when you write some JavaScript test that you want to run through your network, you use this JS script provider, and you pass the JavaScript file to run, but that file should export a run function. You can see, because Zombienet will compile your file and we try to run the run function, and the run function will receive the node name with the name that should run to connect to and run the JavaScript. In this case, I think it's Alice, so we'll receive Alice. We receive the network information, the whole network information with all the nodes, the parachain, everything that you may need to run your file, and the argument that you pass. In here, we are not passing any argument, but you can specify, for example, with, and for example, you specify the argument to pass to that run function as a string, as a quoted string. And if you want to pass several arguments, you just use comma to separate, and Zombienet will split that and pass as a array of arguments to the function. For example, we have, let me show you, I have a few tests for the balance of this network. For example, one cool thing is you may like working on a palette or something like that, and you can check the balance of Alice, and then you can create a simple transfer to transfer from Alice to Bob, and then you can assert on the of the balance of Bob that receive the value that Alice transferred. This is a simple case, but we can, for example, run this with, and we say that we want to test, and the test we want to run is simulate network that feature. And we can see here we will spawn in the network, checking some things of the network. For example, the nodes is up, the block height of the relay chain, and then we run this string 6 to make the transfer from Alice to Bob, and we can check the balance from Alice and then the balance of Bob. You can see also these files. And Zombienet also will inject in your context of your function this zombie keyword that allow you to, for example, has the connect function that will connect to the endpoint that you set, and have also access to the querying. And I think is another thing more. Let me see. You can see what are the test runner. So you get access in Zombienet to the API promise, the querying, the util crypto as util, and this connect function that allow you to connect. So it's very similar to when you are in Polkadot and you connect to and you go to the developer JavaScript, very similar. So you receive the API, the util for hashing, and util for crypto, and the querying. So you receive that. Also, your function, the run function, will run in that context. So you have access to that, and you don't need to import or require in your JavaScript file. We also have support to TypeScript, so you can specify in TypeScript also. We can see here, so everything went okay. The current balance of Alice match. We send the transaction. We wait to find out to be finalized, the block, and also we check the balance of Bob and has the transfer made and the amount that we expect in here.
Super cool. So if you just go back to that, actually, if you don't mind, what we just looked at is the test that you wrote quickly to check the balance transfer, so whether the balance transfer is successful. Where in that test is it written like where is that transaction being signed?
You want to see the transaction or the test file?
Where is? I'm curious to see how the test is constructed and how when you want to submit a transaction, because this is a simulated network, right? So we need to make transactions, right? There's not going to be any events if there's no activity on chain. So I'm curious, there's actually a question, I'm sort of riffing off of a question in the chat right now, is how do you simulate these extrinsics happening? Where does that happen?
So here, the thing that Zombienet makes is just running this function. So Zombienet will also run with the dev account will be there. We don't clean the dev account, so you can specify Alice and Bob, for example, to sign this transaction as Alice. And we have here a hard-coded address for Bob. So when we say that, let me. In this line, when we make the simple transfer, what Zombienet make is just include this simple transfer file in the test runner and run this file, this function. We receive the node to connect to run the intrinsic, and we just send the intrinsic to you.
And could you use other tools so subxt being another way to submit transactions? Could you use other tools? Is there support for that, or is it only using Polkadot.js?
At the moment, we support to submit transaction. We support only Polkadot.js. We have integration to subxt in the roadmap. So
cool.
The idea is to have that in place and support to using both Polkadot.js or Kabi in the future or subxt. So you can select the tool that you want to simulate the extrinsics and things like that. Also, one thing that I didn't mention, but we have in Zombienet is we have a few helpers. For example, for running upgrades, you can specify the chain upgrade, and we have all the extrinsic to run the upgrade for you already set. So there is a definition to make the upgrades.
There's the question, actually, if you don't mind me asking it, it's relevant because what I was asking was, where is this transaction constructed? And clearly it's I imagine in the future where there's a library of these common patterns, right? That like a simple balance transfer or maybe an XEM transaction. But the question that someone else in the audience asked is there a way to simulate real life chain events like slashing, node unavailability? And can Zombienet support the addition and or removal of nodes on the fly while the network is spawned? So can we integrate Zombienet to a real running chain that is public and running?
So simulate slashing or simulate different things could be, I think it could be done but we need to maybe code in the runtime. We have a few tests right now related to slashing in Polkadot that we are working, but you need to also code in the node itself. Related to spawning nodes to a running network is not yet supported. You can spawn the network, for example, with 10 nodes, and you can pause or you can like resume or reset the nodes if you want. It's something that we call commands, and you can, for example, pause a node that will pause that node, that process or that pod will be paused. Resume that node, or you can restart the node. You can, for example, say, I want to restart the node after, I don't know, like 30 seconds, something like that. So we just kill the process for 30 seconds and just restart the process again. But you cannot spawn a new node as part of a feature file. It's something that we are working, but it's not yet done. The idea is just to, you can specify all the nodes in the, or the idea that I'm working is that you can specify the nodes in the network file, in the tone file, but you can say that this node should be off in the start of the network. So all the node will be, the command and all the things should be processed, but the node will be off. We will not run the node, and you can also in the feature file say, okay, start the node that is off, for example. That is the one idea we are working for support that is like adding nodes to a running network.
Cool.
But it's not yet working right now. It's
in the roadmap.
That we want to. Yeah, it's something that we are working because it's open the door for several use cases that, okay, I have this network and I want to just add a few more nodes, something like that.
Mm-hmm.
Yeah.
Cool.
Okay, let's back to the presentation. These are a few examples, similar the way that I showed before. We have the well-known function, the metrics, the histogram. This is the definition of a test histogram. When you can define, for example, we had two buckets in here and the between, the system event, the custom JS, and the use case that we support right now, or the Zombienet is working right now. As I mentioned before, we are using Polkadot in GitLab CI. We are using in Substrate Connect through GitHub Actions, and Cumulus also with GitLab CI. And we are working in a project for benchmarking right now, but it's a working project. It's not yet done. But the idea is to also have support for different CI. At the moment, we have GitLab and GitHub Actions already working. Maybe in the future, we maybe want to include, for example, Circuit CI or Travis, or we want to explore different integration with different CI to make Zombienet useful for everyone in the community. And related to a roadmap, a few things that we are working, as I mentioned before, we are working on more Rust integration, especially with SubXT. We are working on inject some network faults or chaos testing, adding more providers. We are checking Nomad and also Docker as provider. And also we want to move right now the test runner, the parser for the feature file to a grammar parser. That is also a work in progress task. It's almost ready to be included in the next version, but it's not yet in there. So at the moment we are using a parser is basically a regex, and we want to move from there to a more robust and more user-friendly grammar parser. And that is the end of the presentation with some acknowledgement and contributions. As said before, we take inspiration and several patterns from Polkadot Launch and Simnet. And I encourage and we encourage everyone to use Zombienet, to test Zombienet, to provide feedback with new features or things that they want to, like, if it doesn't work. We always accept issues, reproducible issues. And if you see something, new features or things that you may think that it will be useful for the rest of the ecosystem, you can open issues for feedback, and we are looking to collect feedback for not only for internally using Parity, for the rest of the teams, and to provide a better tool for everyone.
Super cool, Javier. This is like this has been great. Thank you so much for like making the time for this. I'm curious. You had on your slide the ability to coordinate attacks using Zombienet. What does that look like? Maybe you can give an example.
Yeah, so it's something that is built. We don't have like a or for showing the example is like we have the idea of having a back channel. I don't have right now like a working example to show you, but Zombienet support a back channel between the test runner and the nodes, in this case of Polkadot nodes, because you need to compile the nodes to have this back channel integration. So you can, it's like a start architecture where the test runner is in the center and it's relying all the message from the different nodes. And the test runner has access to all the information he received and relay the information to all the nodes. So if you have your nodes compiled to support this option of the back channel, you can send message to the test runner, for example, and you can say, okay, this like I don't know, this hash is a garbage or anything that makes sense for your test. You can send the information to the test runner to the test runner, make the assertion aware of this hash or aware of this thing that they need to test, and all the nodes also receive this information. So it's a very advanced feature that we developed with Zombienet with the parachain engineering team. But I don't have right now a working example to show. But the idea is to have this back channel between the test runner and all the nodes. And all the nodes will receive all the information. So we rely on the information to all the nodes. So you can coordinate the information for different nodes, and the nodes can behave differently between because of this information they receive from other nodes or from the test runner. And the test runner will assert things based on that.
Mm-hmm. Super cool. I mean, Zombienet, it's so clear how it's really the catalyst for creating an easier playground for developers working on parachains. I think, and that's really one of the goals with our developer ecosystem. You know, we're really lacking sort of an easy way to spin up networks and test them and try things that, well, as part of the building cycle of things. I guess like another question I have, and this might benefit people in the audience. You know, we're talking about this tool is obviously very useful for integrating into your CI. You know, if you're a parachain team, running a whole bunch of tests. DevOps probably, you know, would also benefit from, you know, relying on such a tool. But who for you really is the target audience of Zombienet? And maybe in the vision of Zombienet, who do you think is going to benefit the most? Who do you see benefiting the most from using Zombienet?
Okay, that's a really good question, because we started working with Zombienet internally, and the target audience was the different engineering teams in Parity. But at the moment, we are looking for exploring to expose Zombienet to the rest of the teams in the ecosystem. And one idea that someone proposing the Zombienet repo is to have a registry for the parachains. So make easy to run different configuration with Zombienet with different parachains, and with the real, like Zombienet provide a registry where each parachain can provide information about the image that they build, for example, or the repository of the binary, and make easy to spawn a network, for example, with different parachains onboarded, like, I don't know, like Moonbeam, Akala, or different parachain from the ecosystem, and make easy to the teams to work in integrations and to test integration between parachains. So at the moment, we are looking for collect feedback about this registry. There is an open post in the Polkadot forum related to Zombienet registry, and our vision is to have this tool to be more useful for the rest of the ecosystem and not only for internal use in Parity. So we are like looking patterns, we are looking new features and stuff to make useful for the rest of the team. Maybe they want to spawning a network with different configuration, different parachain, using XCM is something that we have in the roadmap to see like if we can create easily a playground where the parachain can like play using Polkadot.js or just create testing for things with integration with different parachains and running through Zombienet. So at this moment we are like looking to explore and grow the target audience for Zombienet outside of the internal use that we have in Parity.
Yeah, that's so exciting to hear. I really think that like it all of these like our developer ecosystem, it's all about collaboration. Like we collaborate a lot, and the more and more we see these new parachains, the more and more we realize it's important that this collaboration exists. When you're opening channels between parachains on Rococo, it's very useful because you need to test certain behaviors and stuff. So I really see Zombienet being powerful there. I also think it would be so great to have all of these common tests that parachain teams will need to run in one place. Sort of this is the standard industry standard. This is the things that you need to be testing on your parachains. Like, we don't really have that right now, right? So I think that would be really cool to see grow out of this project too.
Yeah, I think that is also I think we can explore, like create I don't call like it's like also a registry for testing or a base of testing that everyone agree that okay, this is the like the industry standard for testing these things, and we can just create a new repository for those tests or including Zombienet and allow that like reuse those for each team, and not everyone just like writing or reinventing the wheel for that for each team.
There's a question that came up. The question is, are there any good practices to follow to write a Zombienet oriented parachain Docker file?
Zombienet oriented Docker file?
Yeah, so for writing a Docker file for Zombienet, is there any good practices, best practices?
I would say that not about practices. Zombienet doesn't need much in the image that you build. I found some issues with the image that doesn't that remove, for example, bash, that in the hardening process of the image remove all the comments that make harder to work with Zombienet, but it's working now with a few changes. But no, it's a standard image. For example, you can take inspiration of the image that we build for Polkadot or in the Cumulus CI. That image work very well with Zombienet. So it's not like any best practices for that.
Awesome. Well, Javier, this has been really, really, really useful. I want to ask the last question before we sign off. What's the most exciting thing that you're looking forward to with the Zombienet project? And it could also be like, what are you looking forward to seeing other developers use Zombienet for, or contributing to the project? Any words on that?
Yeah, I think one of the most exciting things that we have or I have in my mind is growing the target audience and see if we can reach the different teams and they try to start using Zombienet and this kind of idea of registry that they want to spawn, very easy, a network with different configuration, with different parachain. I think that will open the door for any kind of like integration testing between different teams, and that is super useful for me. And we are like working on making that easy also. Is to try to not make like very complex, very like hard configurations, something like that. We are trying to make it easy, maybe expand our CLI to allow to just spawning from the CLI with different parachain. It's an idea. But yeah, I think that is.
I want to say shout out to Nikos for the CLI.
Yeah.
Because it looks really nice. I mean, good UX goes a long way, right?
Yeah.
I see that he's contributed a lot to the JavaScript side of the project. So
yeah, all that beautiful output is for Nikos. Yeah.
Yeah.
So yeah, and also we are working to be more integrated with the Rust code. Maybe also provide Zombienet as a create library, and you can specify directly from Rust and not try to and don't need to run as a separate like process or something like that, and allow you to integrate in your Rust test for the teams in the ecosystem. That is also like a work in progress right now.
Super cool. Well, I think that concludes our seminar. This has been really educational. I hope that this is a useful resource for everyone else, like rewatching this. Go hang out in the repository. There's probably a lot of stuff that's going to happen between now and 6 months from now. Who knows? But the key things is, Zombienet, it allows you to spawn a network and run tests for it, and that's super powerful. I think there's like the foundations for a really powerful and exciting tool for our ecosystem. So thanks so much, everyone in the audience too. You know where to find us. Also, check out the Substrate Seminar repository, and feel free to suggest some topics that you'd like to see on this. So with that said, Javier, I wish you a really great day, and everyone else as well.
Okay. Thank you. Thank you very much, and thank you everything.
Ciao.